Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at complex data types in STL. I thought we'd finish with the STL section, but I remembered that I wanted to add one video on complex nested data types. So there's nothing really new in this video, but I just want to show you that you can use nested STL types to represent any data structure at all, no matter how complex it is. So let's take, for example, let's use maybe vector and map. So just using these two types, we could have vectors of maps, maps of vectors, vectors of maps of vectors of maps. We can have whatever we want. We can nest these however we like to represent an arbitrarily complex data structure. If you do start finding yourself using a vector of maps, you might want to consider using instead a vector of a data type that you've created, some class that has fields for things like name and age or whatever you want to have in there. So what I'm about to show you, sometimes it's useful, but you should always think about whether you can simplify things by declaring some of your own classes, because nested data types do look a bit sort of messy. But let's say, for example, we want to have a map of vectors. So I'll declare a map here that looks like this. We could have, let's say, a string as the key, and the value could be a vector. Let's say it's a vector of int. Let's say that this is a list of test scores for various people. So we'll call it scores. You might get some warnings in CDT when you do this, just because there are bugs in CDT, but you shouldn't get any warnings when you compile the program from the actual compiler in the console. So we could use this like this. We don't have to get the vectors out of there and set them and put them back or anything like that. We can do stuff like scores, and then we're accessing the map here. Let's call this one Mike, and then we can access the vector value in there directly just with push back. Let's give Mike a score of 10, and I'll just copy that, and we'll have like two more. So we'll say on his second test he got 20, and we'll have maybe someone else in here. Let's call her Vicky and give her a score of 15 on the test that she's taken. Then we can iterate through this just with some creative nested loops. So to iterate through the map, we could say for, and we need this type again. At this point, the auto declaration in C++11 would come in handy, but we're going to look at that later on, so I'll stick to the old way of doing it for the moment. So say this is iterate it equals scores.begin, and it's not equal to scores.end, and it's plus plus. So now we're getting out of that. Well, the key is just a string, so we can say string name equals it arrow first. Remember, we use first and second with a map, and the value is a vector of int in this case. So we can say vector int. Let's call it score list equals it arrow second. We could already output the name here. Let's output name like this, and maybe have some punctuation there, and we'll use flush so that we can keep the following output, the actual score results, all on the same line. Then we can iterate through the vector, so we could use, for example, an index-based loop, int I equals 0, I less than score list dot length, score list dot size we need there, and I plus plus. And here we could output the various scores. Let's say cout score list and I. Whoops, try to get the right kind of punctuation in there, and let's maybe just have a space after that and output flush. You could put commas in, but then you have to use like a Boolean flag so that you don't put commas like after the last item or something. So, and then let's just do cout like this, and see how that looks. So after we've output all the scores, we'll output just a new line. So I've got like a warning here, but it's just CDT being peculiar. If we build this, we shouldn't see any warnings or errors. And if we run this, we should see our list of scores like this. So this is a pretty common technique. You should always think about simplifying it with your own classes, but sometimes you just need some kind of really complicated data structure to represent data from a file or whatever. And then you can nest these STL classes to whatever depth you like. So if you want to practice this, it's worth doing. You could try inventing some data structure. Maybe try something like a map of vectors, or a set of vectors, or a set of decks, or absolutely anything you like. You can even try nesting these even more deeply if you're really enthusiastic with this. But it's worth trying out once. And don't forget that you need to have spaces, at least with this compiler, around your kind of nested type declaration there. You can't do it like this, at least not with this compiler. And even if you could do it with your compiler, it's certainly less confusing to put some spaces around the nested type there. So do have a go at that. Declare some nested type, use it to store some complicated data structure. And that's it for this tutorial. Until next time, happy coding.